I'll just do a quick little recap then if no one could hear me, and we can dive into that. So this is episode 1 of 8 from Camp, the summer series, Chain Abstraction Master Panel. We're here with Stefan from OneBalance, who's also from Frontier Research, who are behind Cake Framework, building lots of amazing things within the chain abstraction stack. So very keen to dive into that a bit later. But Stefan, if we could start off with how you got started in all of this racket and how you got roped into the chain abstraction master panel. It'd be amazing to hear your background.
Cool, sounds good. So previously I was working at a company called Flashbots. I was one of the co-founders there. And the big focus there was figuring out what is the impact of the increasing amount of bots that are interacting on chain, and what impact really does it have on the protocol layer. A lot of it was sort of focused on how do we think about mitigating some of the negative externalities that come from MEV and the appearance of all these bots. But my interest in that space had started prior, when I was looking at things like account abstraction, smart contract accounts, and how do you do gas abstraction for users. Back then, I guess this was in 2019, 2020, is when we started seeing a lot more people using stuff like relayers to be able to bring transaction on chain without having the user needing to spend the gas itself. And so that was the start of, I guess, my interest in the concept of chain abstraction and how to improve the UX of using blockchains. I think the full circle for me is that it's coming to the realization that chain abstraction is really about the introduction of a solver layer that intermediates user interactions, and enabling that architecture has a whole host of implications across the stack.
Amazing. So there's a lot to dive in there, which is going to be fantastic. I can't wait to pick your brain. I've listened to a few podcasts that you've been on recently, and I'm very excited to speak a little bit more. Before we do that, Jasper, if you want to just give a quick little intro to yourself, and I mean, we've heard your intro 1,000 times here on SEDA, so I'd love to get sort of your take on where chain abstraction is at now and what you're excited about now that there's a lot of collaboration on chain abstraction happening in the industry.
Yeah, sure thing. So I'm Jasper, CTO and co-founder at SEDA. Before I was doing like scalability research for Ethereum, building L2 infra before rollups called Plasma, state channels, etc. Yeah, I'm excited. Chain abstraction is actually the thing that got me like really, really excited about the space again. Because for the past few years, all we've been hearing is like, stop building infra, start building consumer apps. And then you try to build consumer apps and it's just impossible because it's too expensive or the UX just sucks. And we're finally figuring out like, as blocks plays gets commoditized across all of these L2s and becomes like very affordable to make on-chain transactions, I feel like we're finally getting to a point where if we unify this layer, we can actually start building consumer apps and we can build mainstream applications, which is very exciting. Yeah, so that's what I'm excited about chain abstraction. What was is that it?
Yeah, that was perfect. Nailed it. That's exactly what I wanted to hear. So this is the way I'm going to split the conversation up today. Guys, I would love to sort of talk a little bit about like chain abstraction, how we ended up here, why it's important, and then I would love to go on a bit of a deep dive into two things. One being Cake Framework that was put forward by Frontier Research, and then more specifically on what OneBalance is doing with credible accounts and sort of walk through how that operates. So just as this is episode 1 of Camp, which is going to be an 8-episode series, Stefan, I'd love to hear from you, kind of like, what's the industry's evolution up to this point that makes chain abstraction perhaps a necessity for the industry in order to move forward? How did we get here?
Yeah, I have a fun anecdote here that I guess shows that I've suffered many wounds of working on this stuff. Um, so if we think back of when Ethereum got started, we never had the concept that there would be many smart contract blockchains. The thinking was that there would just be one. It would be Ethereum, and we would have sharding and blah blah blah, and all of these things would be figured out. Um, what we developed back then was the JSON RPC API, and the concept of sort of externally owned accounts, right? We sort of inherited some of these things from Bitcoin, and then also developed some of it as part of the EVM. But never within the development of the EVM was there the concept that there would be multiple different chains. And in many ways, the EVM itself and the design of the JSON RPC API hasn't kept up with the demand for greater scalability and greater access to block space. And so through time, we started coming up with these scaling solutions, and we pivoted as a community towards a rollup centric roadmap for scalability. Yet the type of accounts that we use and the virtual machine that we use has never adapted towards enabling the seamless transition to those rollups. And so it's sort of inevitable that as part of this, we ended up with a higher level of fragmentation. The anecdote to share here is for anyone that's developing on Ethereum, you're familiar with the concept of chain ID, which is how you prevent, you basically route a transaction to one chain or another. So each chain selects a chain ID, and then you need to put that in the message that the user signs. But chain ID didn't exist until the DAO hard fork in 2016. In fact, prior to that, right, because there wasn't the concept of there being two different chains, a single a message that's signed by a user could be replayed on every other EVM chain. And so it was chain ID was sort of an afterthought bug fix that was inserted as part of the transaction format as a response to what was sort of an exploit out in the wild where people were playing replay attacks. So I think that's a useful thing to think about, which is it was never designed from a first principles to have multiple execution environments, and that led to a lot of fragmentation and difficulty with the user experience. I think what we're doing as an industry now with chain abstraction is just realizing that, holy shit, some of these ecosystems that have emerged more recently that have had like a more focus on scalability have been able to keep a very good user experience while still achieving scalability. And Ethereum right now is struggling to figure out how to actually provide that good user experience. And chain abstraction is sort of the answer, which is, okay, we can develop new tools that allow us to provide that same experience as is being found in other ecosystems while still remaining Ethereum centric.
Do you think that the way that people think about chain abstraction, or more specifically, when you talk about chain abstraction, are you talking about chain abstraction on top of Ethereum in competition to these other ecosystems that are developing chain abstraction? Or are you thinking about it as a concept that will theoretically wipe this idea of ecosystems to the user, to the new user coming in? It'll just feel like one.
So I think Ethereum users have the highest level of pain point, which is why it makes sense to sort of start there. But in reality, what chain abstraction aims to achieve is a user experience where the user never thinks about the chain that they're on, they never think about the bridge that they have to use, and they never think about the gas that they have to pay to interact with that chain. So all of those things are sort of hidden away from the user. But in the ideal world, what you can do is that you can hold Bitcoin on Bitcoin and still buy meme coins that are being launched on Solana. Using those Bitcoin. So I think that's like a very clear way to represent what chain abstraction is. And in this scenario, it doesn't touch on Ethereum at all. If you think about today, what's the way to do that? The only way to do that is to go through a centralized custodian, right? If you want to go from BTC to Solana, you go to an exchange, you swap into Sol, then you go to Sol, and then you do what you want to do on Solana. Chain abstraction aims to provide that same experience, but in a fully non-custodial way, where you don't even have to think about the bridging aspect. You just directly go and do the action that you want to take.
You proposed the cake framework, which has put a lot of, I would say, like a massive amount of excitement throughout the industry. A lot of projects now coming forward and talking more about chain abstraction. And I love what you were just saying then about, eventually for the end user, they're not going to feel any of sort of the pain points, whether it's on Ethereum or whatever ecosystem. But now there's lots of other frameworks or lots of other everyone's talking about how do we go about doing this. Do you see the repetition a potential for repetition where we end up having frameworks battling frameworks, and we end up with more siloed tech stacks, one version, which is chain abstraction version A, and then someone else is doing chain abstraction version B, but they're not able to work together? Are we going to end up repeating the same things?
I do think that that's somewhat of a risk. You know, the goal with chain abstraction was to try to unite the language. The cake framework was to unite the language that people use. That sort of tends to be the first place where we start to see fragmentation emerge, is people build the same stuff, they just call it different things. And then it like confuses a lot of other people, and then it like makes it seem like there's competition in, you know, the design of things. Really, it's fundamentally architected the same way. So the cake framework was like, okay, guys, let's create a venue where we can have conversations over the language that we use to describe these things, putting an emphasis that we sort of agree that the solution here is this solver layer that intermediates the interactions. And so that was an attempt at helping to reduce down the amount of confusion that there would be. I think from the user standpoint, I do expect there to be many competing solutions to chain abstraction, and that's a good thing. Like, you want competition and approaches for how people resolve the outstanding issues, and then eventually the industry as a whole will align on a specific approach to chain abstraction. I do sort of believe that there's, it's mostly technology driven. So the solution that will make the most technical sense will sort of win out. But there's always sort of a distribution game here also that people tend to play to be able to capture market share. So we'll see. We're in a fertile environment now where everyone's excited and building different approaches and trying to get them adopted. And I see all of that as being beneficial, because it means that we'll have a diverse approaches to solving the problem ahead.
How opinionated should the abstraction solutions be, in your opinion? Right, or does the opinion, or like the opinion comes in at the apps? Like, how are you seeing that? Like, should the framework or the initial, the foundational architecture, or middleware, should it have strong opinions, or should it be mostly configurable?
What do you mean by opinionated here? Do you have an example?
Well, you're seeing a lot of people that are building. So I mean, a lot of people are saying like the cake stack right now is super collaborative, right? Like, everybody tries to make this thing work. Everybody's working towards chain abstraction. A lot of people are working on completely different part of the stack, but there's still some competition. And what you're seeing a lot is like, essentially, people are building products without leaving certain things empty, right? I think it's normal, right? Like, but like, yeah, I'd like, where should the configurability sort of like come in?
So it's always like a balancing game, it feels like to me. Like, you can never reach 100% of all desired use cases, but also if you only reach 20%, like, you may not succeed. I think the approach that makes the most sense generally, and this is not necessarily specific to like building a chain abstraction framework, but like building anything, is like start niche, target like a specific use case, have the wedge, and then start to grow from there. I think that there's a fundamental truth, which is what OneBalance is sort of trying to build off of, which is, if you want to do secure cross-chain interactions, you need to make credible commitments to solvers. And then the approaches to like making those credible commitments can be opinionated on a variety of different, you can call it types of order flow, right? And so you may have some system that aims to make those credible commitments that's better for payments, some other that's better for swapping use cases. I think it's an open question for me, which is how much will different types of order flow benefit from using the same commitment machine versus using specialized commitment machines. Another way to think about this, where like opinionation may like emerge, is even within the swap use case. There's this trilemma that we've sort of discussed in the cake framework, which is around when you're creating an order flow auction or an order flow system or a solver network, you have to pick what you're optimizing for between the price optimality, so giving the user the best gas price or the best price on the swap, speed of inclusion, and reliability. And then sometimes we also discuss permissionlessness as being a factor in this. But each one of these factors are sort of different points on the design space that I sort of see different teams optimizing for. And we'll see. There's another one that's like emerging more and more, which is capital capacity. So like it's easy to do like a swap for like a retail user that's like sub $10 on a cross-chain basis, but to do a transfer which is like 10 million, it's all of a sudden like breaks the system. So yeah, depending on the use cases, I sort of see different designs optimizing accordingly.
So let's do it there, because you were talking about the credible machine, which I'm not a tech guy. I'm learning very rapidly with this whole chain abstraction thing, but I've listened to you speak multiple times about this. So let's use that as a segue to dive into what you guys are doing at OneBalance, because I believe that kind of this idea of credible locks, this idea of using a credible machine, is bespoke to your system, to what you're doing at OneBalance, correct? Could you sort of explain how OneBalance works? And for anyone who's interested, there's also a really great little video on OneBalance Twitter page, which is a really good explainer. But let's walk through it. How does OneBalance, the credible accounts, operate?
Yeah, so we presented this idea of the credible stack, which is, you can say a representation of the cake framework. The credible stack being what we sort of believe is a necessity to enable cross-chain interactions to be secure and reliable, which is introducing accounts that are built on top of credible commitment machines. Now, credible commitment machines are just blockchains, realistically. The core idea behind Ethereum and Vitalik when he created it was you want to have a blockchain that's able to enforce arbitrary contracts, and the ability to have some third-party computer thing that you can trust, that is like mutually trusted. Let's say that myself and Jasper want to come into a transaction. We can put our faith in the 500,000 validators of the Ethereum network that they will correctly enforce the contract that we've entered into. And so what that allows you to do is to make sort of commitments that can be relied upon by the counterparty, even though you are sort of mutually distrusted parties, because you do mutually trust the execution of those 500,000 validators. The insights that we brought is that in the relationship between users and solvers at the time of doing a transaction cross-chain, it's overkill to rely on 500,000 validators. It's too expensive. It gets the job done. If you look at any of the bridges that exist today, that's how they work, right? You send a transaction to Ethereum to deposit into the bridge contract, and then the bridge operator goes and like does some action on the destination chain. But it's too expensive to do that when you want to do it on every single interaction. And so there's a necessity to allow the users to specify the source of trust that they want to mediate an agreement that they enter into with the solver. And so that's the core insight. The core insight is users can bring an arbitrary source of trust in their interaction into with a solver. Now, this is all like fairly technical. So what does this actually enable? Well, realistically, what this enables is like near instant transactions from any chain to any chain. And that's kind of the mind-blowing part. If you finally, you can sort of have an experience that's essentially a centralized exchange experience while being connected to all the chains and all the assets traded on all the chains. So you get all the benefits of speed and cost of a centralized exchange, but you get all the advantages of access to all the chains and all the tokens from being native. Plus, you retain the fully non-custodial aspects of it. So it feels a bit like magical in the abilities that it ends up delivering. But it's all based off of the construct that you don't need to do everything on a single chain. The accounts can bring in trust at the time of transaction execution, depending on the action that they want to take.
To some extent, and this is the first time I thought about this, you are essentially, you're using a solver's. It's almost like a credit debit system,
Mm-hmm.
right? Where you essentially you are spending credit while a solver is spending debit, and everything just gets settled in the backend. So you get this idea of instant finality, even though there are still processes going on in the backend. It's makes sense.
Yeah, it adds these layers, right? Then you have clearing houses that help net things against each other, so you can find efficiency. Um, every scalable system is built in layers, and you don't want instant settlement on everything. You want instant fulfillment, and then you can have delayed settlement that benefits from the efficiencies of scale.
So what are we outsourcing here from the sort of like legacy model to solvers, and what are we outsourcing to the critical commitment machines?
So solvers do the liquidity finding and routing. So the job of a solver is, well, they take a few risks, but one of the risks that they take um, is settlement risk. So if they are guaranteeing a leg of the transaction, and the chain that they're executed upon reorgs for one reason or another, they're sort of eating that risk. But they can price that in as part of the execution of their transaction. The other thing that they're doing is routing. So let's say that you're swapping, and you want to have the best price. It's up to the solver to figure out, is that best price on Binance, on chain, wherever it is. It's getting settled on chain regardless, but it's up to them to figure out how they manage their inventory that's deployed across all the different execution environments, to make sure that they provide reliability. So those, I'd say, are the two main jobs. I know that there's others that I'm forgetting right now. For the credible commitment machine, its only job is to issue, secure, and fulfill what we call resource locks. So it just prevents a user from double spending without requiring the user to make a transaction on chain. That's its only job. So once you send a request to the credible commitment machine, that request is sort of accounted in its accounting, debit or credit system, as you mentioned, and then the user is unable to spend that again. People are quite familiar now with the architecture of rollups, so I think it's like the easiest way to think about it. Like, a rollup could be considered to be a credible commitment machine where the user just deposits funds into it, and then the sequencer is what's preventing the double spend, right? So the sequencer is processing all these different messages, and it creates a canonical order. That order is not necessarily settled yet, but you can have third parties that listen to that ordering and then consider it to be a valid, credible order because it was provided by the sequencer. So, yeah, in that framework, the sequencer is sort of acting as a credible commitment machine.
Is it a manual action that the user has to do from their externally owned account? Do they have to move any money into a credible account? And then when they make that transaction, is it then moved again to be held until the commitment has been verified and the transaction is done? And then that's left. Well, for a user, how simple is it to use this credible account?
Yeah, so that's something that's an area that's actively being developed. I think the next session you guys are talking with the folks at Socket, and the Magic Spend Plus Plus is like another way of achieving this credibility on accounts. At the end of the day, and the problem is an EOA key. If a user uses an EOA key, it has the ability to equivocate. So that's the fundamental challenge that's being solved here. By equivocation, I mean, a user can sign two different messages with the same nonce, and both of those messages are considered valid by the chain, right? And that's the thing that we want to prevent, because if you sign two different messages and you send one to one solver and another to a different solver, then you create a race condition where only one of the solvers is able to get it on chain, and then the other one gets griefed essentially. And so the way to solve this is you need to restrict the capabilities of the EOA in some way. We call this adding credibility to the account. And you can do so by depositing inside of a smart contract wallet, for example, and then start using the smart contract wallet. Or you could deposit it into just like a new smart contract that's open with some counterparty solver, right? So it could be like a deposit account inside of some other framework than pure accounts. Our current thinking is that you get a lot of benefits from transitioning your entire account into being credible, that if you just deposit sort of a subset of your balance into it, it may create more confusion. At least having everything in one place and then being able to use it anywhere seems to be more beneficial than to have to keep track of, okay, I have like this amount of USDC deposited with this person and then this amount deposited with that person, and keeping track of all of this doesn't achieve the full chain abstraction that we think is necessary.
And for the solvers, right? So the solvers, to me, when I listen to you speak and the way that you speak about the solvers interacting with the intent that the user does by making the transaction, seems like the solvers are kind of like the magic here in a lot of sense, that they're doing everything that the user would not traditionally have to do in Web3. But how restricted are solvers right now, right? Like, where are solvers at currently? Because in order for my understanding of what industry-wide chain abstraction would allow, there would have to be an industry-wide interoperability, which would mean that these solvers would have to have liquidity ready and connections to each single chain. And if we're just deploying app chains left, right, and center, and there's thousands of these things, is it going to be like a chicken and egg or a cat and mouse where there's just more chains than solvers can keep up with?
The winning solver will have liquidity on the destination chain, and if there's no solvers that have liquidity on the destination chain and a user issues an intent that wants to interact with the destination chain, then it's up to the solvers to get liquidity there if they want to, right? Like I think that's sort of like the thing you'll see is it will just become competitive, and solvers will hold inventory on chains that see a lot of flow. But that's how I see it. Stefan, please.
Yeah, I think you guys are both right. At the end of the day, this is a marketplace that's two-sided. There's a demand side, which is transacting on a chain, and there's supply side, which is like a solver having inventory on that chain. A lot of folks are trying to mitigate, this bootstrapping of like solvers. There's a bunch of different ways to do it. My theory is that much like we've had people give token allocations to market makers to like support an exchange, we'll see the same thing with chains saying like we're going to give a token allocation to market makers for them to be solvers on our chain, and then it makes my chain like easier to access for people. So that's like a neat way to solve the like bootstrapping problem of solvers on a chain, because you can just have the people that really want activity on that chain subsidize essentially the liquidity that gets added there. The other thing I'll say is that in the ideal market landscape, there's the ability for solvers to specialize. So a solver can say, I only do Ethereum Gnosis chain route, right? And so as a OneBalance user, maybe I use that once, but the one time that I use it, I use that solver. And then the majority of my interactions are maybe on Ethereum Solana, and then that's like a different solver that fulfills those. And so this is where it creates the room and the demand for these solver networks that are able to sort of auction off orders or auction off order flow to solvers depending on how they specialize within the entire network of possible routes.
You're muted, Matt.
You're muted.
Oh, sorry. A lot of buttons here. It's like a radio station. That got me thinking, you've got a massive background in MEV, and this is a question I think I asked you, Jasper, once upon a time, but would love to get your take on it. I'm not sure if it's a silly question, but with all these solvers competing, do we open up a new style of MEV where solvers can start to front run each other when they see other solver transactions coming in, and they can then try and beat that solver and race down to zero? Or how is this going to play out?
Yeah, this is all MEV. Chain abstraction is all MEV, I think, is sort of one of the insights here. The reason why is the second that you enable a permissionless external party to take some activity, you introduce a principal agent problem. And this is a hat tip to Chris from Anoma. I've started framing MEV as being more of a principal agent issue. Because the interest of the solvers is just to maximize the amount of value that they extract, right? That they can make from a specific transaction, and so the MEV problem in chain abstraction is how do you restrict the ability of solvers to be able to be predatory towards the user? What is like the fair price that the user should be willing to pay for it, without compromising, some of the experience that they're looking for. I do think that many in this sector don't sufficiently think about MEV. And the reason why is it's relatively easy to just say, oh, I'm going to work with a single solver to start. And then I'll kick the can down the road to see, oh, how do I actually add other solvers to this? But then that's when the can of worms really sort of starts to open up, right? Is when you start to have multiple different solvers involved.
Then you're all of a sudden you have two solvers, but now you need to think about auctioning mechanisms for your two solvers, and it becomes pretty wild. Yeah, that is a good one. Like, so how are you guys thinking about this, bootstrapping it? Are you guys just talking to all the big solver networks?
Yeah, so this refers to the order flow trilemma that we previously mentioned. We're not interested in building a solver network ourselves. We think that there's some really difficult auction design problems to be solved there. And we want to really focus just on the accounts, so creating the CCMs, issuing and securing resource locks. And that will be, our value add to the chain abstraction stack. But yeah, so working with existing solver networks, and then bootstrapping over time. I think for us, it'll be a big question of figuring out which solver network is better for certain types of order flow, and then figuring out when to route what order flow to which network. That will be sort of our focus. To start, the property that we care about the most is reliability. So we want reliability of execution for our users, and we care about that more than we care about price.
Nice. Makes sense. And then, enough about solvers.
If you are actually a user and you're excited, jump to Balance's Discord or Twitter on the website. Actually, I think it's OneBalance.io. You can sign up for your whitelist at the moment, right, in order to get involved with the credible accounts. Is that correct? Anyone who wants to get in?
Yeah, so you can just go to OneBalance.io and people can sign up for the whitelist. We're going to start delivering capabilities to accounts gradually over time. And so, yeah, you can start building your account score, building points. We're going to have a bunch of different questing systems that help enable people. And so, yeah, it'll be our goal is to create the best cross-chain experience that exists. And I think we have something pretty good going on. Something that we haven't talked about is the role of oracles in all of this. Are you going to get to that?
Actually, where I wanted to go right now, which is why I plugged your whitelist now, because I wanted to so if anyone's listening in, sort of the flow here really is users create a transaction, solvers then do the transaction on behalf of the user, but someone's got to be able to verify that this is happening somewhere, right? Is it, from what I understand, we're talking with like Enzo Finance, what they're doing is that an intent could be a multiple chain transaction, right? Like I want to do 3 or 4 different things. They all involve different chains. So there's a massive element of verification, especially with the credibility locks, as you refer to them, right? Is like somebody has to check these, to check that the solvers are completing the transactions, what the state is. So Jasper, maybe that's a great opportunity, so to speak, with these frameworks that are coming out now, such as what OneBalance is doing and other frameworks that we're seeing. How does SEDA fit into the picture here?
So OneBalance is unique in the sense that they have this concept of resource locks. And to those, you could say that the oracle is the key. However, it can be a quite complicated key, depending on the complexity of the resource log. So if it is a really, really complex resource log, it might be quite difficult to get a centralized Oracle provider to provide you with this data specifically. And or it could also be complex in the sense that it's unique data on like some obscure new L2 that the user wants to interact with and the solver is willing to interact with, right? So I think here is where SEDA really shines. It's the fact that you can just write your own data feed to serve as a key for this resource log is really, really powerful as a concept, because it allows you to essentially, if we stick with the metaphor of keys, it allows you to sort of like create your own resource log keys, and then any solver can verify that that resource log key essentially does what it should do, and you can use templates, etc., and sort of like create trusted templates for certain actions. And I think it fits really well within the permissionless aspect of chain abstraction, right? Like the idea is not that OneBalance will become an arbiter of like which chains you get to interact with, or neither should SEDA. So there should be these sort of like permissionless frameworks or middleware or infrastructure, whatever you want to call them, to interact with any chains, and permissionless sort of like programmable omni-oracles are in my opinion necessary. So yeah, I'm super excited about this. Like this is, yeah, Steph.
If we assume that there's going to be millions of rollups, you quickly get to a place where you're like, holy shit, how do you create storage proofs for all of those rollups? And the easiest way to do it is to incentivize those proofs rather than to build them yourself. And so that's sort of how I've been thinking about like the role that SEDA plays here. It allows for creating arbitrary incentivization of storage proofs that can then be fed into whatever escrow mechanism that is used for triggering actions.
Can we break down just a little bit those storage proofs for people listening in that might not be so technical? Why are the storage proofs such an important thing here in an incredibly cross-chain world or chain-abstracted world?
So when I say storage proofs, I guess it can be like interchangeably used as just state proofs, which is like you need to prove that the state of a certain destination chain is what was requested. So when you create a resource lock, what you do is you say, okay, I have X amount of USDC locked up within my account. And this becomes, this can be claimed by the solver if they prove that a specific state transition on a destination chain has occurred. And then that specific state transition can be something like, I have an NFT that I want to buy deposited into my account. So that state of the NFT being in the account is the thing that the solver needs to create and then bring back as a proof to the system to say, okay, now I can claim the value that I've that was offered to me. So yeah, that the state proof is just the state transition that was requested took place and can now be used to unlock the resource lock.
And then if you extrapolate this, like you can batch like 1 million transactions even at some point, right? Like let's say the credible commitment machine or the OneBalance model, like Stefan said, they value sort of like execution over speed maybe, or at least over cost in the beginning, right? So the idea is that you could even batch many user interactions into a single resource lock if you wanted to. And the more complex these resource locks get, the more important it is that you have like super flexible state proofs.
So how does SEDA's design, so from my understanding of that, is a user could issue an incredibly complex transaction, right? Like multiple, like I said earlier, multiple transactions on different chains, and someone has to prove somewhere that those transition states took place and what was the outcome, whether they were successful or not. What is it about SEDA's design that makes that possible? What does that look like from a developer's point of view that wants to use these modules to issue these complex queries?
So, I mean, first of all, it's important to say that if you create some insanely complex intent doesn't mean that it will get fulfilled. If it's too complex too early, like solvers are not going to do it. However, like where SEDA comes in, or like the uniqueness about SEDA comes in here, is the programmability. So you could issue a single resource lock key or Oracle request that would verify many state proofs, or that would consist of many state proofs, or it would just return true or false, checking the conditions of the state on many chains, and it's completely verifiable, right? So a solver can read the code of the that would result in the state proof and say like, okay, this indeed does verify the state for me, so I'm willing to like perform these actions in fulfill this intent for the user, knowing that there is a key to unlock the lock.
So where are we now? Because OneBalance, you've put forward the credible accounts and everything that goes within that. There's a lot of other frameworks. Obviously, SEDA, we're building to sit as Programmable Oracle Infrastructure to allow what Jasper was just explaining. How far away are we from achieving what we might call a V1 chain abstraction experience, which may not be all ecosystems, but maybe some? What's to come next?
I think we're there already. Like, so the accounts that we've built, I think, are essentially providing chain abstraction. We're avoiding the hard problems in a way to be able to like bring the future closer, by saying, okay, it's, as you mentioned, limited to certain chains, and certain types of interactions. But yeah, it should be ready for people to start playing around with within the next month or two. And yeah, the future of not having to worry about gas or about chains, or about bridging at all, I think is essentially here. I don't believe that there's any fundamental constraints or research questions that remain unsolved.
Jasper, what's your take on that from building from the opposite end of the stack?
I think it's finally here, but I think we'll see it very soon. I don't think there is a good example yet of this specifically. The closest thing has been a cross, and it's been live for a while. That's like the most sort of like, in my opinion, magic intent experience that's been live for a while now. But sort of like extrapolating that across the entire space and across many chains and not having the concept of a chain yet, it can be extremely close. It's just like how quickly can people marry all of these or weld all of the cake frameworks together? How quickly can they bake the cake, if you will? And so the constraint now is time, which is good. That's a great constraint to have.
And then in your opinion, what comes next? We do chain abstraction, we have these accounts, we then have an amazing UI UX experience. Does that necessarily lead to adoption, or what do we need to see to get that adoption then, like in terms of maybe on the application layer? What applications do you think are going to be built first that are going to make this adoption?
Yes, you want to try to answer that?
Yeah, sure. I think it's the very important test whether what we have been building is important at all, actually, because as soon as you can mimic the Web2 experience and still nobody uses it, it means that what we build is essentially not very useful to everyday people. But to me, the most obvious use cases would be probably a payments app or a social app that has payments built in. Like, I think that would make a lot of sense. Cross-border payments. I still think payments is like the biggest product market fit crypto has today. So the experience can be improved there, and using having like a fully non-custodial payments app that has maybe it's like a social plugin allows you to do certain things that you maybe wouldn't be able to do if you were building it in a custodial way. You can do a lot more experimentation. So I'm expecting a lot of experimentation there. And actually now you're seeing it a lot with the Telegram stuff that's going on, like the Telegram bots, but you also have now a bunch of Telegram apps that actually see a ton of usage. They're quite silly. It's like these weird clicking games but they are crypto enabled and they get a ton of usage. So maybe that is actually one of the first real chain abstraction use cases as well. Steph, what do you think?
Um, yeah, we're excited to have people build on top of OneBalance accounts because I think that it will allow for a new style of builder to come. Like the ones that don't care about the blockchain, they don't care about the ecosystem that they're on top of. The only thing that they care about is the the technical properties that the chain is offering them. And then what chain abstraction gives them is a way for users to onboard from anywhere. And that's like the biggest thing that they've been missing, right? Like application developers today, when they go in to build on a rollup, they're like, which rollup ecosystem do I want to build on top of? Because they're like, which users are there already? Which is like very strange thing to say. It's like, you know, do I pick AWS or do I pick GCP? Like, okay, who are the users of GCP right now? And then like try to like go develop on that stack because of that. So that I think is just like a framing of application development on crypto that is going to change because of chain abstraction. It'll be where the technology is the best to be able to deliver the product experience that's desired. So our goal is to make it as quickly as possible for these application developers to build on top of OneBalance accounts. And then I suspect that we'll have a bit of an unlock on in capabilities for these, and we'll see new style of applications emerging.
Yep, that's great. I agree. Like I always say that the thing that excites me the most about SEDA is like the permissionless sort of like essentially having an HTTP extension for smart contracts and the new use cases that would enable when people can't truly build anything. Historically, it was like, yeah, but it will be expensive. But as that will soon no longer be necessarily a problem, I think it will be very, very interesting.
Yeah, I think what both OneBalance and SEDA are doing is you're solving this. We talk about a lot at SEDA, this kind of chicken and egg problem of like needing to get data first in order to bootstrap your protocol or whatever. But by removing those technical complications, not having to choose what ecosystem you're building on, it just simplifies the whole process. That takes away a massive barrier of education for the builders that you're talking about, Steph, that maybe don't really even care too much about some of the stuff that we care about in Web3. They just kind of want to build, right? And if they don't need to then learn all the things, amazing, right? Let's actually, it reminds me of something that I worked in esports and Web3 for a long time, and an esports team once told me, they said you're creating solutions to problems people don't have. Is what they said. That was 4 years ago. So I think we're finally getting past that point, hopefully now, and people will just start using the tech without having to worry about the tech, right? I mean, that's the whole point of chain abstraction. We are coming up to the end of the hour, Steph, and I know that we're going to be diving more on oracles later with the credible oracle spaces as well. So make sure that anyone listening in jump into that at 6 p.m. CET by OneBalance. Steph, if you just sort of drop a little bit of alpha, or anyone who wants to get involved in OneBalance, where do they go? What's coming up in the next 2 to 3 months to look forward to?
Yeah, the call to action here is really sign up and create your OneBalance account, start to build an account score. We're always hiring, of course, so if you're interested with the vision that we're building towards, then please come join the fund. And yeah, let's pull the future into the present.
When can we start building the first locks for resource? The first keys for resource locks.
So in our development right now, we're starting with like a very simple verification method that doesn't require these complex keys, I guess as you put it. But I think as soon as we start opening up for third-party applications to come develop, that's where it's going to make a ton of sense for them to also be able to script their keys.
Well, amazing. Well, we're looking forward to going on the journey with you. What's happening at SEDA in the next couple of months? Jasper, what's happening in the engineering team to look forward to?
So we started drafting and drawing out the first integrations this week. So we have a engineering meet next week in which we will probably build the first one, which is really, really exciting. And yeah, look forward to announcing that and having people actually use some of our technology, even if it's on DevNet to begin with. But yeah, look forward to the first integrations going live on DevNet, and then mainnet after. Yeah, that's it.
It's going to be amazing. It's an amazing 6 months for SEDA, amazing 6 months for OneBalance and beyond. Steph, I know you've been doing podcast after podcast, so I really appreciate you coming on. And I believe there's another hour of power happening later at 6 p.m. CET from the OneBalance account. Jasper, you're also going to be there to discuss credible Oracle. So anyone who wants to dive deeper into what SEDA's doing and what's happening on the transport layer or the settlement layer within chain abstraction, do join that space as well. Thank you both for coming, and very much appreciate it. And we will speak to you both very, very soon.
All right, cool. Thanks for hosting, Matt. Steph, talk to you in an hour.
Ciao, guys.
Yo, bye.
Bye.